How are you, my friends? This is review questions number 1 on pre-calculus topics related to lectures 17 to 32. Question number 1, given the function f of x 3 secant half times x over 2 minus pi over 2. Graph this function and find the interval or intervals where the graph is above the x-axis if x between minus 3 pi to 5 pi. Now this is the whole answer here. We have to rearrange the function to find the correct argument. So we can multiply the half inside. It will be 3 secant x over 4 minus pi over 4. This is the argument. If you take 1 over 4 outside as a common factor, then you have x minus pi. So there is a shifting here for the secant function, pi units to the right. You can see here, shifting to the right, pi units. So this point was at 3. Because to graph this secant, you have to graph the cosine first. Cosine will be dashed, and then the solid one is the secant. See this point here, pi, see this point? It was at 3, and that's the cosine. This is the cosine shifted to the right, pi units. Also, we can find s is the starting point. Put the argument is equal to 0. X over 4 minus pi over 4 is equal to 0. X will be pi. So the graph will start from pi for the basic period. For e ending, put the argument equals 2 pi. So x will be 9 pi. See, the 9 pi is there. So from 3 pi, see, this is the cosine until 9 pi. Divide the period into 4 equal parts to know the vertical asymptotes. See, these are the vertical asymptotes of this secant are the zeros of the cosine. So we have 3 pi, 7 pi, and we have also minus pi. So let's look at the interval from minus 3 pi to 5 pi here. We need the graph above the x-axis only in this interval, which is minus pi open to 3 pi. Now, question number 2. Cosecant of alpha divided by secant of alpha minus cotan of minus alpha, all divided by 1 over tan of alpha minus tan of minus alpha. We have to make it looks like m plus n cosine of k alpha. Then we find m plus n plus k. So let's start with the left side. You have to go slowly here and simplify everything you can, like cotan of minus alpha. This is an odd function, so you can write minus cotan of the alpha with the minus becomes plus. Same thing for tan of minus alpha. Write the cosecant of alpha 1 over sine of alpha. Write secant of alpha 1 over cosine of the alpha. Use the division here, a over b divided by c over d. Multiply a over b times the reciprocal d over c. Now here in the numerator you have to add, but they have the same denominator, sine of alpha. That's easy. Here we have different denominators, sine of alpha, cosine of the alpha. You have to find LCD. So now we have cosine squared up of alpha plus sine squared of the alpha. We can continue here. We get 1. Also, we have to use the same division of 2 fractions. 2 cosine of alpha divided by sine of alpha times this one here. This is like the d. Sine of alpha cosine of alpha divided by the 1. See, that's the formula here. Now you cancel sine of the alpha, you get 2 cosine squared of the alpha. We remember the lowering power formula for cosine squared of the x is equal to 1 plus cosine of 2x divided by 2. When you cross multiply, you get 2 cosine squared of x is equal to 1 plus cosine squared, cosine only of 2x. So 2 cosine squared of alpha becomes 1 plus cosine of 2 alpha. So we can compare now with the given in the question. We have to find, so m will be 1, n also is 1, the coefficient of the cosine, and then the coefficient of the alpha is 2. So this is k2. So when you add m plus k will be 4. Question number 3, find the value of sine. Inside the bracket, we have tan inverse 4 over 3 minus r cosine 12 over 13. So what can we do? We have to let here inside, let two angles, u is tan inverse 4 over 3. So I can find tan of u will be 4 over 3 y over x. Then I can find r, which is 5. The second angle, let v is equal cosine inverse, which is the same as arc cosine 12 over 13. So cosine of the v, 12 over 13 x over r, then I can find y. So from the triangles, I can find sine of u, cosine of u, and then sine of the v, because I have already cosine of the v. Then I apply the formula sine of the difference. So it will be sine of u minus v. It will be sine of u cosine of the v minus cosine of u sine of the v. And we can continue here on the next slide. Put the formula. Sine of u we have 4 over 5. Cosine of the v we have minus cosine of the u 3 over 5. Sine of the v 5 over 13. So you add and subtract here the fractions, you get 33 over 65. Question number 4, if the function f of x is equal to square root of 3 cosine pi x plus sine of pi x is written as f of x is equal to w cosine, inside the bracket we have mx plus n. Find the value of wm divided by n. Now be careful here, there is a little trick. Let's see, the function given something cosine plus sine, so we can use the reduction identity. Capital A is the coefficient of the sine, which is 1. Capital B is the coefficient of the cosine. Then I find k, which is 2. Now I need to find phi. Sine of phi will be b over k, cosine of the phi will be a over k. So phi now is in quadrant 1 because both are positive, and phi will be pi over 3. So I can change the given function into only sine, which is k sine x plus phi. Now remember, the x here in the formula is everything in the argument here, pi x. So I write the function, the given function, as 2 sine pi x plus the phi, which is pi over 3. But I need the function to be written as cosine. So I can use cofunction identity. So I convert the sine into cosine. So it will be 2 cosine pi over 2 minus the argument here. Simplify that, you get minus pi x, and there's a minus pi over 3, and this is pi over 2, so it becomes pi over 6. Now we can take minus as a common factor inside the argument. It will be minus pi x minus pi over 6. Remember, should be a minus inside here. And then cosine function is an even function. So cosine of minus theta is the same as cosine of the theta. So we can remove this minus easily. So it will be 2 cosine pi x minus pi over 6. Now I have to compare with the function that we need. So w is 2, m is the coefficient of the x, which is pi, and everything after the plus. Here you see plus n, so you should put here plus. The minus will be inside the bracket. So this is n is equal minus pi over 6. Put everything there in the expression, you get minus 12. Question number 5, solve the system, which is a linear system. 3 over 4x plus half y is equal to 5. 3 over 2y plus 1 over 4x is equal to minus 1 by Gauss-Jordan elimination method. Let's call the first equation equation 1, the second is equation 2, and we have to rearrange it. Notice that x and y locations in the second equation here. See, this is y and x. We have to make it x and y to write the augmented matrix. So the LCD, we can multiply the LCD here, the equation by the LCD 4. to make the equation simple. Multiply by 4, multiply by 4, multiply by 4. Remember, 20 here. Let's call this equation 3. Also multiply by 4 the second equation. You get x plus 6y is equal minus 4. Now ready, write the augmented matrix. 3, 1, 2, 6, 20 minus 4. We have to make the first number 1, so we can interchange row 1 and row 2. So this becomes 1, 6 minus 4. Down we get 3, 2, 20. Now we have to change this number here, 3 to 0, so I can multiply row 1. Remember, this is row 1 by minus 3, the opposite of this, and then I will add. So I will get 0 there, minus 3 times 6, minus 18, and there is a 2 there, down. So minus 16, minus 3 times minus 4. 12, and then you add to 20 is 32. Now we divide here by minus 16 to get 1 there, 1 and minus 2. So this is the y value, y is minus 2. Then I multiply row 2 by the opposite of this, minus 6, and then I will add to row 1. So I get 1, 0, 1, 0. This is minus 2 and 8, so x will be 8, y is minus 2, and the solution 8 minus 2. Question number 6, we have given cosine of 2 theta minus 17 over 18. Theta belongs to quadrant 4. Find the exact value of cosine theta over 2. Now remember, in this question, we have 3 different angles. We have theta, we have 2 theta is another angle, and we have theta over 2 is another angle. So let's use the double angle formula for the cosine. Cosine of 2 theta, 2 cosine square of theta minus 1. Because I need to find cosine of theta here to use it in the formula for cosine half angle. So I put minus 17 over 18 is equal to 2 cosine square of theta minus 1. I take minus 1 on the other side, becomes plus 1. And then I will add the numbers here, 18 over 18 minus 17 over 18. So 2 cosine square of theta becomes 1 over 18. Let's divide by 2, divide by 2. We get cosine squared theta is 1 over 36. Take the square root of both sides. So cosine of theta will be plus or minus 1 over 6. I have to choose either the plus or minus according to theta, because this is cosine of theta. Theta belongs to quadrant 4. So I take cosine of theta 1 over 6 as positive. Now remember, theta is in quadrant 4, so I can write theta as 3 pi over 2, theta greater than 3 pi over 2, less than 2 pi. I have to decide the sign, either positive or negative, for cosine theta over 2. I know where is theta. I have to find where is theta over 2. Just divide by 2 here, this inequality. So theta over 2 becomes 3 pi over 4, and then pi when you divide by 2. So theta over 2 belongs to quadrant 2. So the cosine of half angle theta over 2 is negative. From the formula here, there is a plus or minus. So I have to choose cosine theta over 2 is minus. Put the formula here, 1 plus cosine of the u, which is cosine of theta, 1 over 6 divided by 2. And we simplify that. This is 6 over 6. 7 over 12 inside the radical with the minus outside. Then you split the radicals, minus square root of 7 divided by square root of 12, which is 2 square root of 3. Rationalize. You will get minus square root of 21 divided by 6. Question number 7 is about vectors. Given the vectors A and B, vector A is m minus 1, m plus 1, and vector B has magnitude 10 and direction angle 5 pi over 4. Find the magnitude of the vector A. This is A here. So we have to find m first. If the dot product of the given vectors is minus square root of 8. Let's find first the components of the vector b. So we can use the formula, the magnitude of the u cosine of theta, magnitude of the u times sine of theta. So it will be 10 cosine 5 pi over 4, 10 sine 5 pi over 4. 5 pi over 4 is an angle in quadrant 3. So the cosine and the sine are the same, minus square root of 2 over 2. Multiply each one by 10, you will get the vector v. Minus 5 square root of 2, minus 5 square root of 2. Now the dot product A dot B would be AC plus BD. And the answer, minus square root of 8 from the given. See, the given here, A dot B is minus square root of 8, which is minus 2 square root of 2. Now let's see, m minus 1 times this one here, minus 5 square root of 2, plus m plus 1 times minus 5 square root of 2 is equal to the dot product, the given value. Let's divide all terms here, both sides of the equation, by square root of 2. So this becomes minus 2 here, and there's a minus 5 times m plus 1, and there is a minus 5 times m minus 1. Simplify the equation to find the value for m. You will get m is equal to 1 over 5. Now let's find the components of the vector A. So m minus 1, 1 over 5, minus 1. M plus 1, 1 over 5 plus 1. So it will become minus 4 over 5, 6 over 5. We need the magnitude of the vector A. So it will be the square root of the first component squared plus the second component squared. You will get the number 2 square root of 13 divided by 5. This is the magnitude of A. Now, question number 8, find all the solutions of the nonlinear system 5x squared minus 4xy minus 7y squared is equal to 10. And then the second equation, x squared minus xy minus 2y squared is equal to 0. It's not an easy system here. Sometimes we add the equations or we subtract the equations to get an equation easy. But in this case, it will not work because we have so many different numbers. So instead, we can factor the second equation directly here because we have a 0. So it will be x plus y, x minus 2y. If you multiply these, you will get second equation. So the first factor is equal to 0, or the second factor is equal to 0. So x will be minus y. Let's call this equation m, or x is equal to y. Let's call this equation t. So what I will do, I will take equation m, x is equal to minus y. I will replace it in equation 1 here. So I will get y squared is equal to 5. Please check it. So y will be plus or minus 5. This is y, 2 values for the y. To get the x, I take each y and replace it in the equation m. On the next slide, I will do the same for equation t. I will take x equals 2y in equation 1, and then I will find the y squared is equal to 2, so y will be plus or minus square root of 2. So I have 4 proposed solutions, 2 on the previous slide and 2 here. All of them are correct after you check them. And the checking, it will take time and space. Checking is shown in details on the next slide. So this is the checking. You take each point, first one, second, third, and fourth. Each point you replace it in equation 1 and 2 to check that the right side is equal to the left side. So all points are acceptable. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.